Hey guys, today I'm going to show you how you can get the carbon footprint and energy consumption of a code snippet, LLM inference or LLM training using a library called CodeCarbon. In the end, we will have our energy consumptions and carbon footprints of these. Before we begin, make sure you like my video, comment what you want to see next, subscribe to my channel, etc. And in the end, I will put the GitHub link down in the description. How you install this library is you're gonna come here and it is pretty easy, to be honest, like how to use it and things we are going to do. It is pretty straightforward, but I believe it is very important to know, like there are times that you have to know your energy consumption, your carbon footprint, especially if you are doing some research. Other than the repository, if you just type CodeCarbon, there is the documentation page which shows you some quick starts. For example, basically how you can track this emissions of a code snippet. You just do from CodeCarbon import emission tracker, tracker emission tracker, tracker start, and tracker stop, and it will just track this between. This is the one that we are going to use. However, there are other applications as well, such as starting tasks with trackers or using it as a decorator, etc. Also, we'll take a look at these parameters as well. However, like I said, probably you won't need any of these because it is pretty straightforward, as you will see in a second. First, I'm gonna show you how to estimate electric consumption and your carbon footprint in an LLM inference or any code you like. And then we will do a training and we will see how to estimate its carbon footprint and electricity consumption. For that, let's start by installing the necessary libraries. You're gonna do pip install, transformers, CodeCarbon, datasets, and TRL. Okay, the libraries are installed and let's check out our hardware. So as you can see, we have two GPUs here. And since I'm on a Kaggle notebook, we can just check it out from here too. We have two T4s. Just let's keep that in mind. Now let's do the imports. So as we mentioned, the CodeCarbon library is the library that's going to make us estimate those electricity consumption and carbon footprint. So we are going to import that first. After that, since I'm going to show you how to do it with LLMs, we are going to do from transformers import auto model for causal LM and auto tokenizer, and we are going to import torch, and let's run it. Now the next thing is we want to load our LLMs and tokenizer so that we can do an inference with it. So model equals to auto model for causal LM from pre-trained. I'm using Tiny Llama, this version, because it is tiny. And I'm setting device map equals to auto so that this model can be mapped to the two T4 GPUs we have. Likewise, I'm loading the tokenizer equals to auto tokenizer that from pre-trained and the model path. So this doesn't have a pet token by default, so I'm making it equal to end of the sequence token, and the padding side is right. So let's run this. It may take a while to download the model. Now we are going to define something called tracker. So what this will do is it will basically track the carbon emission and electric consumption. So I'm going to give it only one parameter, which is output file. And this will just basically tell us where to save it. But there are additional parameters you can give it as well. Check it out. Just go to the documentation of CodeCarbon and go to the parameters. So you can see there are a bunch of parameters here that you can use it for your use case. The one that I'm currently using is this, to configure the output file. By default, it is emissions.csv. You can check this out for the different parameters, but this is enough for me. Let's run it. When you run this, it will show you a couple of remarks. So first thing, it will say no CPU tracking mode found. This is because this CodeCarbon library cannot access to this RAPL file. So you can just give it access And here they provide some workaround for this. However, as I understood, even without it, you will get accurate results. Also, it will show you that your CPU, your GPU, your platform, Python system, available RAM, CPU count, your CPU, GPU count, and GPU models. So we can verify this again from here. I have 2 T4s and it detects 2 T4s. So we are all good in here. Now let's actually generate text and get the carbon emission and electric consumption. So for this, we will just do a text generation. Okay, so this is out of the scope to show how to do a text generation, but I just gave a user message, which is a classical YouTube motto. Don't forget to like and subscribe. The key part is before your GPU intensive task, which is model.generate here, you have to put tracker.start and then you have to put tracker.stop. So between these, this CodeCarbon will measure your consumptions. Let's run it. It will also start giving you some outputs like energy consumed for this, for that, etc. And this is our results. Result of the text generation, which you don't have to care. Now let's look at the file that is actually generated. In my case, it will be saved here. So test.csv. Now I'm going to download and show you what it looks like. So this is the CSV file that the CodeCarbon output. So we have the timestamp. Project name, you can change it. Just I changed the output file from the parameters. We have the duration of the execution. This is our emission. This is our emission rate. We got CPU power, GPU power, RAM power, CPU energy, GPU energy, our energy consumed. This is, it turns out, where we are running our code in, United States and South Carolina. This is important for the carbon footprint. So as you can see, you can get your emissions here and your energy consumption. Also, additionally, you can see your Python version, your GPU count. As we discussed, we have 2 GPU, 2x Tesla 4, and this is how you get your consumption rates. Okay, so we did estimate the consumptions for an inference of an LLM. Now let's see how we can track for a training. For this, I'm gonna first restart my notebook. Actually, the funny part is you don't have to do anything. Okay, for example, if you are using, in case of HuggingFace trainer, it automatically just estimates everything if you load this CodeCarbon. For example, I created a dummy training script. Okay, as usual, we have this emission tracker. Actually, we don't even need this. We can just remove it because it does it by default. So this is just a dummy training script with some small data. And I haven't set anything about the CodeCarbon, but by default, it adds it to the trainer as a callback. So it is integrated into HuggingFace. So with this callback, it will automatically call this CodeCarbon and it will measure your electric consumption, energy consumption, carbon footprint, and save it. So let's run this dummy training. Again, you can see the usual outputs such as our GPU count, CPU count, energy consumed, etc. If we go again to our files, I output this training into model train. So our CSV file containing the info we want will be under the model train and it will be by default in emission.csv. So this is the CSV file that contains the consumption of our training. Now I'm gonna download and we will take a look at it. And this is just the same with the previous one. Unsurprisingly, we have the duration, emission rate, GPU power, raw power, energy consumed, emissions, and country. So this is the end. Overall, we looked at how you can get your carbon footprint, energy consumption of an LLM training or an inference. Not just inference, but you can do it for anything. But I believe the most common use case will be text generation, so I did with it. This was a quick video. I hope you learned something new. Like this video as mentioned here and subscribe to my channel and see you at another video.